Hi everyone, welcome back to 10th standard maths class. We are dealing with the chapter circles. In the previous video, we have finished some problems from the third activity, but most of you feels difficulty to solve this problem. So, let's solve this problem first. After that, let's continue the activity. Okay. So question is, in the picture, AB and CD are mutually perpendicular chords of the circle. Prove that the arcs APC and BQD joined together would make half the circle. Okay, this is a question. Let's draw the rough figure and after that I will explain the question. So this is a rough figure. Here you can see that this chord AB and CD are two perpendicular chords. That's already given. AB and CD, these two chords are perpendicular. This is a perpendicular sign. Okay. Now we need to prove that these two chords cut the circle into two arcs. That means here APC by using the endpoints of these chords. APC, that means this is small arc. Okay. And DQB, this is a large arc. Okay. Now question is, when we join these two arcs, that means this APC and this DQB, when we join this DQB and APC also, when we join this, it makes half the circle. That means this will be a semicircle. That is, we need to prove here. Okay, this will make half the circle. D, Q, B, then from that APC also, from the same point APC, this will make half the circle. That is, we need to prove. Now in order to get a half circle, what will be the central angle? Half the circle means what is the angle in that? It is 180 degree. Okay, so it is enough to prove that sum of these two arcs central angle is what? 180 degree. Okay, it is enough to prove central angle of these two arcs sum will be 180 degree. Okay, so for that, first of all, let's join D and A. Okay, let's join these two lines like this. Okay, first join this, then we will get one triangle, and let's give the name to the central point. That means in this point, let's mark the points as what? R. Okay, so we will get one triangle ARD. Okay, this is the triangle ARD. Now this is the central point. Okay, this is the center point O. Okay, now in order to get the central angle, we need to join this A and C to the center point, because A and C are the end of the arc APC. Okay, so just join A to O and O to C like this. Okay, so this is the central angle AOC. This is small arc APC. Central angle is AOC. Okay, now we need central angle of this arc BQD. That means B and D also we need to join to O like this. B to O and D to O like this. Okay, that means we need this central angle portion and this central angle. Okay, now here check the triangle ARD. Consider triangle ARD. Okay, so here in this triangle ARD, you can see that this angle is 90 degree. Okay, this angle is 90 degree. Now let's consider this angle. Here these two angles are not given, only 90 degree angle is given. So let's consider this angle as x degree. Okay, just consider this angle as x degree. Okay, that means angle ADC. Angle ADC is x degree. Now consider the central angle. Central angle starting from A and ending at the point C. What is the central angle? AOC. Okay, if this angle ADC is x degree, angle AOC will be what? half and double relation we learn, no, that we can apply here. So if angle ADC equal to x degree, if angle ADC equal to x degree, then it's a central angle AOC. AOC is a central angle. So central angle will be what? It's double. Okay, half and double relation. So this is x degree means this will be double, that is 2x degree. Okay, central angle will be 2x degree. Next, let's consider the angle BAD. In the small triangle ARD, you can see that this angle will be what? These two sum is 90, because the one angle 90 degree means the next two sums will also be 90 degree. So this is x degree means this will be 90 minus x. Okay, so angle BAD, for our convenience we need the starting point as B. That's why we start from B. Whether it is start from R or whether it is start from B, both are same. Okay, so let's consider that angle A as BAD. Angle BAD is 90 minus x. Okay, so angle BAD equal to 90 minus x means what will be the central angle? Central angle is what? Start from B and end at the point D. So BOD is the central angle. So angle BOD equal to its double, 90 minus x degree. Here whatever be the angle there, its double will be central angle. So 2 into 90 minus x is the central angle. Okay, now we got both the central angle of these two arcs. Angle APC's central angle is AOC, that is 2x degree. Next, arc BQD's central angle is BOD, that also we got 2 into 90 minus x. Now we need to add these two and we need to check whether the answer follows 180 degree. Then we can say that form a semicircle. So let's add that too. So angle AOC plus angle BOD equal to 2x plus 2 into 90 minus x. Okay, next let's add this. First one 2x plus, let's open this bracket, 2 into 90, that is 180. 2 into minus x, that is minus 2x. So here plus 2x, here minus 2x, that we can cancel. Then what will remains here? 180 is the final answer, 180 degree. That means sum of these two central angle 180 degree. That means these two arcs will form a semicircle. Okay, so this is the answer. Okay, now let's continue the activity from page number 59. Okay, now next question is question number 5. Question is, in the picture, bisectors of adjacent angles of the quadrilateral ABCD intersect at PQRS. Prove that PQRS is a cyclic quadrilateral. Okay, one large quadrilateral is given, that is ABCD, and adjacent angles bisectors are joined to the opposite side. Okay, now after drawing that bisectors, we will get one small quadrilateral, cyclic quadrilateral, that we need to prove. Okay, PQRS is inside the circle, but we need to prove that is a cyclic quadrilateral. Okay, so let's draw the rough figure. After that, let's do. This is a rough figure. Okay, here you can see ABCD, one large quadrilateral. Then adjacent bisectors, that means angle A and angle D. These two angles bisectors are joined at the point S. Here these two angles bisectors, that is joined at the point R. Okay, similarly PQRS, these are the joining points of each two bisectors. Okay, now after that we will get one quadrilateral inside this, that is PQRS. You can see one quadrilateral PQRS. We need to prove that this PQRS is a cyclic quadrilateral. That is the question. Okay, so in order to prove this as a cyclic quadrilateral, we want to prove that opposite angles as what? Supplementary. That means angle P and angle R sum must be 180 degree. Similarly, angle S and angle Q sum must be 180 degree. But here nothing is given. Okay, none of the angles are given. So let's consider this angle as 2x, angle A whole as 2x. As it is bisector, we can consider this as x and this as x. Okay, so total 2x means 1 half x, second half x. Here let's consider two angles as y. Okay, 2y, angle B as 2y, then angle C as 2z. So this is z, this is also z. Then here complete angle as, let's consider it as 2w. So 1 half w, next half also w. Okay, now we know sum of angles of a quadrilateral is what? Sum of angles of a quadrilateral is 360 degree. That means angle A plus angle B plus angle C plus angle D equal to 360 degree. Okay, now angle A is what? 2x. So 2x plus 2y plus, so when we add all these, we will get 360 degree. Then 2 is common here, that I took outside. So 2 into x plus y plus z plus w equal to 360 degree. Let's take this 2 to this side. That means 360 by 2, it is 180 degree. So we got x plus y plus z plus w equal to 180 degree. Let's consider this as first equation. We need this for the further steps. Okay, so let's consider this as first equation. Okay, now let's find each angle. Okay, so let's start from angle R. Okay, we need to find angle R. So in order to find angle R in a triangle, if we know at least two angles, it is easy to find the third angle, isn't it? So in order to get this angle R, we need to consider the triangle, this one, angle ARB. Okay, consider the triangle ARB. So in this triangle ARB, only R angle is missing. This part is x degree here, this part is y degree here. So only missing portion is this one. So in order to find this, what we can do? Sum of all angles, that is 180 minus x plus y is enough. Okay. So when we consider triangle ARB, we will get angle R equal to 180 minus x plus y, because this is a triangle, first angle A, that means a portion. In this triangle only x angle is we need to consider, here only y we need to consider. So sum of angles 180 degree, so 180 minus x plus y. So this is angle R. Okay, let's consider this as equation A. Next, we need the opposite angle of R. Opposite angles must be supplementary for the cyclic quadrilateral. So if we consider angle R, we need to consider angle P also. Sum of these two must be 180 degree. So in order to find angle P, which angle we can consider with at least two angles that we know? Okay, so here angle P means triangle DPC we can consider. DPC. In this DPC, angle D is angle W. Here angle C will be Z degree. So next let's consider triangle DPC. Okay, then angle P will be what? Angle P will be 180 minus Z plus W. Okay, so 180 minus Z plus W is the angle P that we can consider as equation B. Okay, so for the quadrilateral PQRS, we got two opposite angles, angle R and angle P. Angle R as 180 minus x plus y degree, angle P as 180 minus z plus w degree. Now we need to prove that sum of these two is 180 degree. Okay, so for that let's add these two. That means equation A plus equation B. Okay, so angle P plus angle R equal to 180 minus of x plus y plus 180 minus z plus w. Now here 180, here also 180, both are positive. So 180 plus 180, answer will be 360 minus here x plus y, here z plus w. Both are same sign, that is minus. That means we need to add all this and put the same sign. That is x plus y plus z plus w. Okay, now 360 minus this one. This we already found. What was the answer of x plus y plus z plus w? In the starting itself I told you, first equation we need to consider, because that we need, that is here. X plus y plus z plus w equal to 180 degree. That 180 degree we can apply here. So this is equal to 360 minus 180. 360 minus 180 is what? 180 degree. That means angle P plus angle R we got as 180 degree. So one pair of opposite angles we got as supplementary. Next we need to prove angle S plus angle Q sum also 180 degree. Then we can say that this is a cyclic quadrilateral. Okay. Next we need to find angle S and angle Q. But you can see angle S. Angle S means at least we need a triangle with the two angles. Okay, so angle S, here no point, here no point. That means this triangle not possible to consider. But angle S is a part of DAS, for the part of triangle DAS. Okay, DAS part is angle S, but these two are what? Opposite angles. So whatever be this angle, the same will be here also. Okay, whatever be this angle, because angle S is a common point and these two will be opposite angles. Opposite angles are always equal. Okay, so if we can find this angle, we can say that this also same. So here it is not possible to consider a triangle because here no triangle, but here one triangle with two angles. So it is possible to consider the triangle DAS. So consider triangle. So consider triangle DAS. So here angle S will be what? Angle S equal to one angle x degree, next angle W. So again 180 minus x plus w. Okay, this is the equation C. Okay, so angle S is equal to 180 minus x plus w. Similarly, in order to find angle Q, here it is not possible to consider a triangle with angle Q here in this side. Okay, no triangle here, but in this side, into the left, one triangle BCQ is there. Okay, so BCQ let's consider with the two angles as Y and Z. Okay, so consider triangle BQC. Triangle BQC. So in that angle Q will be what? Angle Q equal to 180 minus two angles are Y and Z. So Y plus Z. This is equation D. Okay, so angle S is equal to 180 minus of x plus w. 180 minus y plus z is angle Q. Okay, here angle Q means BQC. BQC is the same as quadrilaterals angle Q. Okay, so here also this angle is DSA, but this DSA is the same as quadrilaterals S, angle S. Okay, so now let's find sum of these two, that is angle S plus angle Q equal to, same like the previous case, let's add. So 180 minus these two, so 180 plus 180, 360. Here we need to add all these, so put common sign minus 1x here. Let's write it in order. Next y plus z here plus w here. Okay, so x plus y plus z plus w, that answer we already found, that is 180 degree, that we can put here. So answer will be 360 minus 180. Answer is what? 180 degree. Okay, so for the second pair of opposite angle also we got as supplementary. So these two angles supplementary and these two angles supplementary means what we can say about the quadrilateral PQRS. Quadrilateral PQRS is a cyclic quadrilateral. Okay, so this is a proof. Next is question number 6. Two sub-questions are there. First sub-question is, the two circles below intersect at P, Q and lines through these points meet the circles at A, B, C, D. The lines AC and BD are not parallel. Prove that if these lines are of equal length, then AB DC is a cyclic quadrilateral. That means that large quadrilateral. Okay, here in this figure you can see two circles. Okay, two circles you can see by joining all the points. That means AB to DC, we will get one quadrilateral ABDC. We need to prove that quadrilateral is a cyclic quadrilateral. Okay, let's consider the rough figure first. The rough figure that we need to consider. Here AB is a chord of first circle, CD is a chord of second circle. Okay, now here we need to prove this ABCD, that is ABDC. This quadrilateral is a cyclic quadrilateral, that is we need to prove here in this question. Okay, and one more thing is given. These two circles are joined at the points P and Q. Okay, these 2 points P and Q. Now if the length of this line AC and BD are equal, okay, these two are equal, that also given, AC equal to BD. If these two are equal, what prove that ABDC is a cyclic quadrilateral? That is a question. Okay, now let's consider first quadrilateral APQB. In order to get a quadrilateral, we need one more line here. So for that, let's join this line. Okay, BQ, just join PQ. Okay, so quadrilateral ABQP we will get. ABQP is what? Is quadrilateral inside the first circle. That means we can say that this is a cyclic quadrilateral. Okay, ABQP is a cyclic quadrilateral. Now what is the condition of cyclic quadrilateral? Cyclic quadrilateral means what? Opposite angles are supplementary. Okay, opposite angles are supplementary. That is the condition of cyclic quadrilateral. Now here angles are not given, but let's consider this angle as x degree. Okay, let's consider angle A as x degree. As it is a cyclic quadrilateral, what will be this angle? This angle means angle BQP. I just darken this, otherwise you can see. Okay, what will be angle BQP? This is x degree. So angle BQP will be 180 minus x degree. Okay, angle x here, this will be 180 minus x because opposite angles are supplementary. Okay, now previous section we proved that angle from one vertex and outer angle through its opposite vertex will be equal. So outer angle through Q is 180 minus x. So angle Q's opposite vertex is C here. So this will also be what? 180 minus x degree. Okay, this will be 180 minus x degree. Okay, now similarly let's consider this angle as y. Okay, consider this angle as y. So this is y degree, means this will be what? Opposite angle QPA will be what? 180 minus y will be that angle. Okay, 180 minus y. Now this angle QPA is the outer angle through which angle's opposite vertex? Angle D's. Angle D's opposite vertex is angle P. Through that point P's outer angle is 180 minus y. So this is 180 minus y, means angle D will also be what? Angle D will also be 180 minus y degree. Okay, now in this quadrilateral ABDC, angle A is x degree, angle B is y degree, angle D 180 minus y degree, angle C 180 minus x degree. Now we need to prove this is a cyclic quadrilateral. But when we add this x and 180 minus y, we won't get as 180 degree. X here, y here. But when you consider this figure, you can see that angle side AC and side BD are equal. Okay, like this. Okay, so here these two are equal sides, and in one side angle here x degree, here 180 minus x degree, here it is y degree, here it is 180 minus y degree. Okay, so in this is an isosceles trapezium. Isosceles trapezium. Two sides equal, that means isosceles. Trapezium condition is what? One side sum of angles will be equal. Okay, that is x 180 minus x. Sum will be what? X plus 180 minus x equal to what? 180 degree. X and x we can cancel. So answer is 180. Here also y plus 180 minus y sum is 180 degree. That is isosceles trapezium. Only for isosceles trapezium, sum of angles in one side will be 180 degree. Okay. So we can say that ABDC is an isosceles trapezium. Okay. Now in the previous question, that means I have given one homework. Okay, that is isosceles. Prove that isosceles trapeziums are cyclic quadrilateral. Okay, so from that question we prove that isosceles trapeziums are cyclic quadrilateral. Okay, isosceles trapeziums are cyclic quadrilateral. So here we got ABDC as what? Isosceles trapezium. ABDC is isosceles trapezium. As it is isosceles trapezium, from the previous theorem we proved that it is a cyclic quadrilateral. That means ABDC is a cyclic quadrilateral. Nothing more to write. Okay, you can directly write all the isosceles trapeziums are cyclic quadrilateral. Okay, so this is a proof. Similarly, we can find the second sub question. Next is question number 7. In the picture, points P, Q, R are marked on the sides BC, CA, AB of triangle ABC and the circumcircles of triangle AQR and triangle BRP are drawn. M is a point where these circles intersect. Prove that the circumcircle of triangle CPQ also passes through M. Okay, let's draw figure. Then only you can understand the question. Okay, this is a rough figure. Here two circles here. Okay, two circles, and these two circles are circumcircle of first triangle QRA. Okay, this triangle ARQ. This triangle's circumcircle is first circle. This circle, next circle is circumcircle of triangle PBR. Okay, this circle is the circumcircle of triangle PRB. Here one point M after these two circles meet. Okay, this is a point M. We need to prove that this M is a common point of three circumcircles. That means one more circumcircle will be here. That is for the triangle PQC. PQC is a circumcircle. If we draw, this M will be in that point. That is we need to prove. Okay. So here just avoid these three lines. Okay, let's change this figure. Okay, now I draw one more circle of triangle PQC. Okay, that three lines I just rub. Okay, now we need to prove this M is a common point. M is a common point we need to prove. For all these three circles, M is a common point. So for that, let's join R to M, M to Q and M to P. Like this. Okay. MR, MQ, then MP. Now, let's consider angle A. Angle A as X degree, then angle B as Y degree, then angle C as Z degree. Okay, X, Y, Z. These three angles. Now, for the first circle, you can see one quadrilateral RMQA. Okay, ARMQ. This quadrilateral. If this is X degree, what will be this angle? This angle will be what? X degree here. This is supplementary because all the four vertices are on the circle. That means this is X degree, means this will be what? 180 minus X degree. Okay, 180 minus X degree. Similarly, consider this triangle, quadrilateral BRMP. Then what will be angle PMR? Here one angle Y. So this angle will be what? 180 minus y degree. 180 minus y degree. This angle RMP will be 180 minus y degree. Here also we prove this angle is Z degree. Then this angle will be what? This angle, that means QMP will be what? QMP will be 180 minus Z degree. 180 minus Z degree. Okay, so all these central angle we got as 180 minus x degree here, 180 minus y degree here, 180 minus z here. Okay, we need to prove this M is a common point of all these three. Okay, now here x, y, z, these three are the angles of the triangle ABC. What will be the sum here? X plus y plus z is equal to what? 180 degree. Sum of angles of quadrilateral, it is 180 degree. Now if M is a common point of these three angles, we must get sum of all these three angles as what? 360 degree, isn't it? Okay, angle around a point is what? 360 degree. So if M is a common point, it is divided into three angles. Sum of all these three angles must be 360 degree. Then we can say that this M is a common point. Okay, so let's add all these three. That is, first is what? So central angles are angle RMQ plus angle RMP plus angle RMQ here. Then angle RMP. Next is what? Angle PMQ. Okay, angle PMQ. Then what will be the answer? Angle RMQ is what? RMQ is 180 minus x degree plus angle RMP. RMP is 180 minus y degree plus angle PMQ is 180 minus z degree. Okay, now add all these. 180 plus 180, that is 360. Let's keep 180 here, that we need. Okay, that is plus 180. Here minus x minus y minus z, that is minus common, add all, x plus y plus z. Okay, now this is equal to 360 plus 180 minus x plus y plus z. That means the sum of angles of this triangle that we already wrote, that is 180 degree. That we can write here, x plus y plus z is 180 degree. Now these two we can cancel, plus 180 minus 180. So final answer is what? 360 degree. That means angle around this M point. Angle around M point means, that means this angles of all these three circle what? 360 degree we got. Okay, 360 degree. That means we can say that this M is a common point of all these 3 points, because all these 3 are the angles of this quadrilaterals. Each quadrilateral circumcircles we draw, each quadrilaterals angles. One angle is these 3 angles. That means we can say that this M is a common point. Okay, so this is our answer. Hope you understand. Thank you. See you in the next video.